Hey, what's up, Code Slingers? Welcome back to the channel. Today we're diving deep into a topic that is absolutely crucial for building scalable, performant, and user-friendly applications: synchronous versus asynchronous communication. Trust me, mastering this concept is like leveling up your coding superpowers. So grab your favorite beverage, smash that like button, and let's get started. Imagine you're building the next big social media platform. Users are uploading photos, posting updates, and interacting with each other in real time. Now imagine that every time someone uploads a photo, the entire app freezes for everyone else. That's a recipe for disaster, right? That's where understanding synchronous and asynchronous communication comes in. It's all about making your app smooth, responsive, and able to handle a massive number of users without breaking a sweat. So, what exactly is synchronous communication? In simple terms, it's a request-response cycle where the requester waits for the response before doing anything else. Think of it as a direct conversation. You ask a question and you wait for the answer before you can continue the conversation. It's simple, but it can be a real bottleneck in complex systems. Let's illustrate this with an analogy. Imagine you're at a restaurant and you order a dish. You're essentially blocked until the waiter brings you your food. You can't order another dish, you can't pay the bill, you can't even leave the table until you get your meal. You're completely dependent on the restaurant's kitchen to fulfill your request. Here's a visual representation of synchronous communication. The request goes out, the server processes the request, and then the response comes back. Notice that the client is idle during the entire processing time. It's a direct linear process, but it's also inherently blocking other requests. Now, let's weigh the pros and cons. Synchronous communication is relatively easy to understand and implement, especially for simple tasks. It's great for situations where you need an immediate response, like retrieving data from a database or performing a quick calculation. However, it can lead to performance issues in complex systems, as one slow process can block all other processes. Imagine a website where every request has to wait in line behind every other request. That's a recipe for a terrible user experience. All right, let's switch gears and talk about asynchronous communication. In contrast to synchronous communication, asynchronous communication is a fire and forget method. You send the request and don't wait for an immediate response. Instead, you receive a notification or callback when the request has been processed. It's like sending a letter in the mail. You drop it in the mailbox and forget about it until you receive a reply. This gives you time to do other things while waiting for that reply. Let's use another analogy. Imagine you're ordering a package online. You place your order and you receive a confirmation email. You don't have to sit there and wait for the delivery truck to arrive. Instead, you receive a notification when the package has been delivered to your doorstep. You're free to do other things while the delivery service handles the logistics. Now, let's examine the pros and cons of asynchronous communication. The biggest advantage is improved responsiveness and scalability. Asynchronous systems can handle a large number of concurrent requests without blocking, leading to a much better user experience. They're ideal for tasks that take a long time to complete, such as sending emails, processing images, or performing complex calculations. However, asynchronous systems are more complex to implement, as they require mechanisms for handling notifications, callbacks, and error handling. They can also be more difficult to debug. Let's bring this concept home with some real-world examples, because nothing beats seeing theory in action. In synchronous communication, everything happens in a straight line. You make a request, and the system waits for the result before moving on. Picture this. Your application makes a simple database query to retrieve a specific record. It sends the request, pauses, and waits for the database to respond before doing anything else. Or think of calling a third-party API to check the current weather conditions. Your app sits tight until that response comes back. Even local function calls fall into this category. When one function calls another, the original function waits until the called function finishes executing before moving forward. Now, on the asynchronous side of the fence, things get more dynamic. Here, the request is made, and the system moves on without waiting. For instance, when a user registers on your site, you might send them a confirmation email, but that email can be processed in the background without holding up the whole sign-up flow. The same goes for image processing. Resizing or compressing an uploaded image doesn't have to block the user from continuing to use your app. Video encoding is another classic example. When someone uploads a video, converting it into different formats for various devices takes time, so it's better handled asynchronously. Even user registration itself can trigger multiple tasks, like creating records, sending emails, logging events, all of which can be kicked off without holding up the user. In chat applications, messages are sent and received in real time, but the underlying processes often use asynchronous communication to keep things smooth and responsive. And in microservices, services usually talk to each other through message queues or event buses, making them a perfect playground for asynchronous communication. So, whether it's something as simple as a database call or as complex as a distributed microservices architecture, knowing when to go sync or async makes a huge difference in performance, user experience, and system resilience. All right, Code Warriors, that's it for today's deep dive into synchronous versus asynchronous communication. Hopefully, you now have a solid understanding of the differences between these two approaches and when to use each one. Remember, mastering this concept is essential for building scalable, performant, and user-friendly applications. So, go forth and conquer the coding world. Don't forget to like this video, subscribe to the channel for more tech concept discussions, and leave a comment with any questions you have. Thanks for watching, and I'll see you in the next video.